And here we are after lunch, finishing the notes. You guys ready? Yes, no, maybe?
Yes.
Okay. Sophia's ready, so I'm ready. Okay, so what I was trying to get in before you went to lunch, if you were not listening, was these PRRs, these possible rational roots. The reason we make this is if I don't tell you like what it's divisible by, if I don't give you any zeros, if I give you no hints, nowhere to start, we don't know what to do with this. So we need possible rational roots in order to know how to start this equation. However, that being said, we didn't even look at this equation. And one thing I do want to encourage is always look at our equation first, because you might be able to do something before necessarily needing the PRRs. I love doing the PRRs here because I think it was a nice like little example without having a whole new problem, but I actually don't even need them. I look at this in equation, and do you think we can factor this? Yeah, doing what? Grouping, good, yep. There's a lot of like little hand symbols. We're gonna do our little grouping method, and I think it's gonna actually factor really nicely. So when I say find all zeros, you can always start by saying, can I factor this? Can I quadratic formula this? Can I do anything that I already know how to do? If not, then we're gonna resort to our PRR. So I look to factor it. I'm just rewriting it so I have what I'm looking at. I can take a x squared out of this first one, so I get 2x minus 3. And I can take a negative 2 out of the other one, so I also get 2x minus 3. That becomes x squared minus 2 and 2x minus 3. And then I want to set both of those factors equal to 0 and solve for what x is equal to. So the first one I can do is this 2x minus 3 equals 0. Add 3 to both sides. Divide by 2, x equals 3 halves. I'm also going to do x squared minus 2 equal to 0. Add 2 to both sides, x squared equals 2, and then square root. The only thing is when you square root, remember it's going to be plus or minus root 2, not just root 2. Is it too loud? Should we close the windows, or are we okay? It's fine? You like it? Okay. Am I talking loud enough for you to hear me?
What?
Max? If I'm not, I feel like I'm projecting, but if you're like, I truly can't hear, just ask me, okay? There's nothing worse than someone like muttering under their breath, and you're like, I was literally trying to listen to you, so I'm trying to speak nicely. Okay, so my zeros here are just that. I've got 3 over 2, and then I've got plus or minus root 2. Now, do you see that 3 over 2 is one of my PRRs? We could have searched and found that 3 over 2 would work, but there was no way for us to find plus or minus root 2, because radical 2 is not a rational number, it's an irrational number. So we were able to factor and solve, but both of these, or I guess all 3 of these, plus root 2, minus root 2, and 3 over 2, those are all zeros. So those are all my answers. It says find all the zeros, those are my answers. If it makes you happy to write them separately, x equals 3 over 2, positive root 2, and negative root 2, go ahead and do that. But that's what I'm looking for these last few problems, is actually finding all the zeros. Okay. Okay. All right, shall we do the next one? Okay, let's do our PRRs here. Actually, wait, team timeout. Can I factor that first?
Probably.
I don't think so. It's not going to be as nice as the other one. Just by looking at it, I could take an x squared out of both of these, and I could take like a 2 out of those, but it won't match up. So I cannot factor this. So what I'm going to do instead is my PRRs. So let's go ahead and find our PRRs. Remember, it's the factors of my constant that goes on top. So my factors of negative 6 goes on top, plus or minus 1, 2, 3, 6. I'm just running through that because we just did that, right? You guys good with that? And then my Q is my factors of my leading coefficient, which is just 1. Now, technically, you don't even have to say over 1 because those are just all going to be my answers, right? However, I am your teacher, so I'm trying to be consistent in what I'm doing. So I did all my factors of my constant, all my factors of my leading coefficient. But that just leaves us with all my possible answers are positive or negative 1, 2, 3, and 6. Now, even though we can't factor this out, I'm gonna give you some kind of like scaffolding here. So we're going like little step at a time. So the first one we found our PRRs, but we didn't even need to use them. This time we found our PRRs and we would need to use them, but I'm gonna give you a hint. So if the answer is not one of the first few, I usually try and tell you so you're not spending 20 minutes deciding what counts. So I'm gonna tell you a hint here is that x equals -3. One of my zeros is -3. Now we could have found that. We could have done synthetic division because that's how you find the remainders and we'd want a remainder of 0. We could use synthetic division or even plugging in to find the remainder of 0, but I always start with the smallest number. So we would have to plug in +1 and -1 and +2 and -2 and +3 and then finally get to -3 to get an answer. And I don't really want to do 6 synthetic divisions right now. Is that okay? Call me lazy, but I don't want to do that right now. So I also sometimes might give you a hint. So I'm gonna say this is the one that you should look for. So let's start here. If I give you a hint, then my first step from here is gonna be doing synthetic division to see what happens when I divide that -3 off. So synthetic division, -3. I'm gonna put all my leading coefficients. So 1, 1, -8, -6. Draw my line, carry down. And this should work because I told you so. So if I give you a hint and you find that you don't get 0 at the end, you probably messed up. So I give you a hint, we know it's going to equal 0. We're going to take our answer, and now I want to make it a polynomial. So it's going to be x squared minus 2x minus 2. If we wanted to, we could try and use another PRR. However, when we get down to a quadratic, we have more tools that we can use, right? One tool I could use is factoring this out. I could do, x plus something, x minus something is going to equal that. Will this factor? I don't think so, right? What's another tool that I have to figure out what x is from here? Andrew? Quadratic formula. So that's actually what we're going to do now.
I was going to say
You could definitely complete the square. That would for sure work. It might be messy and we might not want to, but that's definitely a tool that we have. So the cool thing about quadratics is when you get down to quadratics, we have so many more things we can do than just what we were doing before. So this won't factor. So now I'm gonna do quadratic formula. So I might even label quad form, just so I'm like, where did this come from? I'm just gonna solve for x. So x equals -2, which is +2, plus or minus root -2 squared minus 4 times 1 times -2 all over 2 times 1. Everybody's good with our quadratic formula? Okay, I'm going to just simplify and start solving. So 2 plus or minus root 4 plus 8 over 2, which is going to be 2 plus or minus root 12 over 2. And this is why we did quadratics before this, because we've done more quad practice before. We're going to simplify that root 12 to be 2 root 3. And then now I've got all of these 2's, and I can factor a 2 out of all of those terms. And so I'm left with 1 plus or minus root 3. Now, you could make it 1 plus or minus 1 root 3 over 1, but those last 2 ones are kind of redundant. We don't need them. So I'm just going to write 1 plus or minus root 3. That's an answer. That's my 0. So 2 of my zeros here are x plus or minus root 3. My other 0 came from my synthetic division before. It came from my -3. So if I were to write my zeros here, or my x's, x equals all my zeros, it would be -3 and then 1 plus or minus root 3. All of those are my zeros. Okay. Yes, Ryan.
You have to write that.
You have to write this one because it is a plus or minus. If we didn't have it, it's like 0 plus or minus, and that's different. So we do have to have that one. The other two ones are redundant. Okay, we got one more like this, and we got two other kind of different problems. But let's kind of take a team time out and like review the steps that we've done each time, okay? Let's do that. So let's make a little side note off to the side somewhere. I'm gonna write steps because I might be like, I'm doing great with Miss White driving this plane, but if I have to drive it by myself, we will crash. Does anyone feel like that?
Yes.
Yes, that's okay. I don't want you to crash. So let's get some steps to think about. Before we do anything, on this last step, what did I make you do? I said, okay, wait, team timeout, let's do this before we even do our PRRs. We saw if we could do what? Factor. We want to check first if we can factor because we are so good at factoring that we would rather factor first than do any of this other stuff, right? So factoring is always the best first option. So if you can factor, do that first, okay? Then if you can't factor, then what was the next thing that we did on both of these? PRRs. Then we listed our PRRs. Now on the first one, we didn't need to use our PRRs, and on this one, I gave you a hint. But if I didn't give you a hint, / even when I did give you a hint, we had to do synthetic division to figure out what my factors are, or once I know what my factor is, to know what happens when I divide it off. So the next fact, no matter what, is synthetic division. Sometimes you may need to go back from that step and repeat step 1 and 2 like a couple times in order to keep going. But often, and we're going to find this on the next one, and what we just did, once we did our synthetic division, we were down to a quadratic and we were able to do quadratic formula, or we even asked ourselves if we could factor that. So then we're going to see if we can factor or quad formula to see if we could solve from there. So these are the steps that we did that we're kind of thinking through. And we're going to do more of these in 2.5. We're just going to add another more complicated process by adding imaginary numbers, which gets a little fun tomorrow. So first thing we do, we look and see if we can factor it. If we can't, then we did our PRRs, then we did synthetic division, and then last we factored or did quadratic formula. Okay. So let's go down. This is the last one of these examples. We got a couple more problems on the next page, but this is the last one of these examples. I've got x to the 4th minus 3x to the 3rd minus 6x squared plus 6x plus 8. Can I factor that? No, we don't know how to factor something with that many terms, right? There's no comment, there's no GCF, I don't really know what to do, so we're gonna leave it like that. Okay, so I can't factor. So now my next step is to do my PRRs. Remind me, what goes on the top of the PRR? Sorry, what? Oh. Factors of 8, thank you, Barry. I'm gonna do plus or minus, because we always need plus or minus there. It could be positive, it could be negative. Factors of 8 include 1, Billy? Yep. What else are factors of 8? 2. Good, 1, 2, 4, 8. You can put them in whatever order. I like to put them in like smallest to largest, but if it makes you happier to write them in another order, do that. Max.
We're the factors of 8 because like the 8's only one without them.
Good, we always do the factors of the constant goes first. So we did the factors of the constant, and 8 in this term is a constant. And then on the bottom, we do factors of what? 1, which is the leading coefficient. So factors of the leading coefficient, factors of 1 are just 1. Technically, you don't even have to write it over 1 because they're all going to be the same numbers. It's going to be plus or minus 1, 2, 4, and 8. But again, as your math teacher, I'm trying to remind you, it's constant over coefficient, constant over coefficient. Okay, now on this one, I'm not going to give you any hint. We are going to have to use this list of numbers, and one of these numbers will be one of my zeros. Okay? What we do is, like I said in the steps, is we're going to do synthetic division to find out which one it is. And a little word to the wise, I always start with the smallest number. So I'm going to always start 1, -1. If it's not either of those, then I'm going to go to the next smallest number, which is 2. 2, -2. Then I'm going to try 4. So I really don't want to do 8 if I don't have to. That's going to get much bigger numbers. So I like to keep it as small as possible. So I'm going to do +1 just over here. So I'm going to do +1, and we're going to see if it works. So I've got 1, -3, -6, 6, and 8. have it all set up, and now I'm gonna solve. Okay, cool. Did that work? No, why not? What do we want it to be? We don't want a remainder. We want a remainder of 0. So I did not get 0 as a remainder. So I need to do another one. What number should I try next? -1. Now you are welcome to just erase it. Like on my iPad, it's super easy. I'm just gonna erase it. If you're doing it on paper pencil and you're like erasing it's a lot, just put another one next to it. That's okay. Now I'm just gonna try -1. So almost the same, just a tiny bit different. We'll see if it's different enough to work or not. All right, what about now? Does it work?
Yeah.
Amazing.
There's only gonna be one PRR.
There might be other ones, but we only need to use one. Because now I'm going to take this out. I'm going to write this as a polynomial. X to the third minus 4x squared minus 2x plus 8. I'm essentially going back to my steps, and I'm going back to the beginning. If I can factor this, awesome. If I can just go to number 3 and factor or quadratic formula and be done, great. If not, I may need to try another PRR. My question to you is, can I factor this? I think so. I think we can factor it. So let's kind of group the first two, group the second two. I can take an x squared out, and I get x minus 4. I get minus 2, and then x minus 4, okay? Okay, amazing. I did get it to factor out. And now I have these factors. What do I do to figure out what x is? Set equal to 0 and solve. So I've got x squared minus 2 equals 0 and x minus 4 equals 0. Add 2 to both sides. Square root, I get plus or minus root 2. And then x equals 4. And -1, good. Barrett beat me to what the punchline. I was about to ask, okay, what are all my zeros? These 3 numbers essentially, because plus and negative root 2 are 2 different numbers, and 4 are all zeros, as well as that -1. So when I list my x equals over here, I've got to include -1, I've got to include 4, and I need to put plus or minus root 2. Okay, I did not do this with Alpha, but I want to do it with you guys. I want to skip, there's 2 problems earlier we skipped. I think it's in 2.3, and it was F and G. We never did these problems, did we? No, we never did these problems. Now, I told you it was just a simple plug in the calculator and solve. So actually, we may even plug it in the calculator to see what my zeros are, and then we'll take 1 0. From here, though, based on what I've learned, we could find our PRRs, we could check our PRRs, and then we can figure out what all my factors of this are, all my zeros, based on just that. But let's kind of do a little bit of a hybrid model. So let's get our calculators out and let's graph letter F. Oh, come back. I'm going to put x raised to the third minus 7x squared. Not that. Nope. Squared. There we go. Minus 49x and then plus 55. I do think our window needs to be a little bit bigger than our standard window. I might make it, let me try -30 and +30 in both directions. I think that's big enough, but it might need to be bigger. I don't quite remember. It's been a little bit since we did this. I just want a little bit wider, just a little bit farther out of focus of my normal window, and I graphed it. It looks like it could be a fair bit higher and lower. Maybe I'll make my y's go from -100 to +100. Maybe that'll make it a little bit more swoopy of a graph. Oh, still not even that. Maybe 200. It doesn't really matter. I'm just playing with the window so it looks more like a polynomial. That's gonna be good enough for now. I truly don't care what that lowest point is. What I do care about here are my zeros. You see that we can clearly see my zeros? Let's find just one of them, and then I'll show you how, based on what we just did with the PRR, how we find the other ones. So let's find this like most left-hand side zero. So I'm gonna go second, trace 0, and I'm gonna go left of the most left side one. Oh, my calculator doesn't wanna work anymore. You guys find it on yours and then report back.
-5.
You get -5, okay. I also got -5. 1, 2, 3, 4, 5. Do I really need to show that, or we're okay, right? We can all find zeros on our own, okay. So Ava said she found -5, most of you guys found -5. There's 2 other zeros on here. So what we can do is we can take -5 and do what we were just doing before, do our synthetic division, do any factoring, do anything else from there, and find out what my 2 other zeros are. So let's do synthetic division with -5. So I've got -5, 1, -7, -49, and then +55. And again, I'm just trying to find my other zero, so I'm just finding zeros. We found one through the calculator, and I'm using that one to do synthetic division to find the other one. So I'm carrying my 1 down, I get -5, which is -12, which becomes +60, which is 11. That was almost really embarrassing. That's 11, right?
Yeah.
Okay. And then -55, okay, perfect. And then that's 0. If we weren't sure, we can now see that -5 is a factor because we got 0 as the remainder. But we already knew that because we were checking our calculator. Now from here, I can write this as a polynomial, x squared minus 12x plus 11. And I'm gonna ask, can I factor that or can I quadratic formula that to solve for what x is?
I think you can factor that.
You can factor it. What'd you factor it down to, Ava?
X minus 11 and x minus 1.
Good. X minus 11 and x minus 1. -11, -1 multiply to be positive, and then -11 plus -1 is 12. So that means my other 2 zeros should be at 1 and 11. Now, if you wanted to check on your graph, you could go see what your other zeros are. You could second trace 0 on your other 2 zeros and see if they really are at 1 and whatever 11 is. I'm going to tell you they do. So I'm just kind of trying to cross the different boundaries. It sometimes feels like these sections are so different, but they're very similar. We did not do this when we learned 2.3 because I hadn't taught you this yet, right? So I wanted to make sure I taught you this before I start talking about crazy stuff. Cool? All right, questions yet? Okay, I've got one more concept for today, and it's all just synthetic division. It's just about reading a synthetic division problem. So we will not do G. My other class did G. If it makes you happy, graph it in your calculator, you'll see the graph. The last 2 problems, if you go to flip the page and go to the next side, which has 2 problems and then the beginning of 2.5. These say show that 3 is an upper bound of this equation and show that this is a lower bound. What we are going to do, whenever asked us about the bounding of this, we're going to use synthetic division, and we're going to read what that last line is. So I'm going to synthetically divide 3 and this equation. So I'll put 3 in my house, and I'll put 2, -4, 1, -2, and I'm going to do my synthetic division. Okay. Is 3 a factor of this? No, why not? Good. There's a remainder of 19, not a remainder of 0. However, did this ask me to show that 3 was a factor? No. It said show it's an upper bound. An upper bound is if I'm looking at this last line of my synthetic division, if all of the numbers are positive, then it is an upper bound. So if all are positive, then yes, it's an upper bound. This problem said show that. That's one reason I knew that it had to be an upper bound. And then I got all my positives in the bottom of that synthetic division, so that makes it an upper bound. To find the lower bound, we're going to do something really similar. We're still going to do synthetic division, but we are going to read it a little bit differently. So let's do our synthetic division. This time -4 is in my house. And I do my coefficients 3, -1, -5, -3. Carry my 3 down. If you're careful of your positive, negative, I got a little crazy there for a second. I had some crazy numbers here, but again, -4 isn't necessarily a factor, and it very much is not because my remainder is -191. That's not a factor. To tell if it's a lower bound, the signs should alternate. It should go positive, negative, positive, negative. I guess technically it could go negative, positive, negative, positive. The rule for lower is just it alternates. It won't all be negative. It won't all be positive. It's just going to alternate what it is. So this one, if signs alternate, then yes, it's a lower bound. All right. Questions, thoughts, comments? Yes.
So when it alternates, it doesn't matter if it's something positive or negative.
I believe that's true. I believe as long as it's alternating, it doesn't matter. Okay. You do have 2.4 homework due next class, which is tomorrow. We will go over it, and then we'll get through as much of 2.5 as we can, and then the rest will be on video, okay? Let me turn this off.